those that are eating, they have caught them, right? So we're going to look at further calculations on solid mensuration, area and volume of shapes. Area and volume of solid shapes. I hope we have put on our learning gears. I hope we have put on our learning gears. Attention as we kick off. All right. So we have this question. Write and be fast. A cuboid has a diagonal of length. A cuboid has a diagonal of length 9 centimeter. A cuboid has a diagonal of length 9 centimeter and a square base of side 4 centimeter and a square base of side 4 cm. What is its height? What is its height? So that's the question. Are we together? Now we have the options as usual. Like I've always said, I'm not interested in options most times. All I know is if you solve it correctly, you should get the correct answer. Are you following, right? So I have the options there given. 9 centimeter, square root of 65 centimeter, 4 root 2 centimeter, then option D 7 centimeter and stuff like that. So let us look at the question. This question is about which shape? This question is about which shape? A cuboid. What and what do you know about the cuboid? What and what do you know about the cuboid? So this is question number 3. Is that not so? I think we solved two questions before the break. So question 3, that's actually JAMB 1981, but I've told you the year doesn't matter. In this case, for maths specifically, because it's still the same outline covered almost generally. Are you getting me, right? Now this problem is about cuboid. If you look at the question, they give us what? Length of the diagonal. Is that not so? So let us say length of the diagonal is JAMB 1981. The length of the diagonal was given to be how many centimeter? What again was given to us? The square base what? Side. The side of the square base. That is the value of the length. Now, whenever you hear side of something, it's the length of that thing. Are you following? Or the width of that thing, as the case might be. But hey, this is where it becomes tricky. You were told that the cuboid, the base is which shape? The base of the shape, the base of the cuboid is which shape? A square. There is a powerful point there. What do you know about square with respect to the sides? All sides are equal. Are you getting me? So we can say that for the base, the length is equal to what? The value of the side is what? 4 cm. Now, let me ask. If the cuboid is made up of a square base, the length will be 4. The width will be 4. The height of that square base, the height of what? Oh no, a square does not have height. It's just length and breadth because square is 2-dimensional shape. Are you following, right? Length and what? Breadth or width. That's how we refer to square. Are you following, right? So, but squares, you know from our previous class, all the sides are what? Equal. Just like cuboid as well too. Why I'm saying these things that this, for the square base, let me indicate please, very important, for the square base, the length is equal to 4 centimeter, which means that the breadth is also equal to what? 4 cm. Now what did they say we should find here? Height of the cuboid, is that not so? H of what? Cuboid. Trying to define this as much as I can. We don't know. Height of the cuboid, we don't know. But they gave us information that will help us be able to extract some important things about the cuboid. The base is what? The base is what? A square. The base is what? A square. And you know that base is usually made up of length and what? Breadth. Base is usually made up of what? Length and breadth. Which is why area of the base is usually length times what? Breadth. So for this cuboid, We know its length. We know the what? Do we know the breadth? We also know the breadth. The breadth is what value? That's a 4. Because the base is made up of a square. And for square, length and breadth are what? The same thing. So we know the length of this cuboid. We know the breadth of the cuboid. What we don't know now is the what? Height. In fact, let me indicate. Length is equal to 4 centimeter. The breadth is also equal to what? 4 centimeter. Because that guy is square base. Then the height of the cuboid we don't know. Are you following, right? The height we don't know. We know the length. We know the breadth. Are you following, right? But the height we do not know. So this is just the information. Apply your formula. Length of diagonal for length of diagonal. In fact, we know it is cuboid we are talking about. Length of diagonal of a cuboid is equal to square root L square B square H square. Is that not so? Good. From the question, they gave us the length value. So you substitute next. Are you getting me? The length is equal to 9. In place of length of diagonal, you fix 9. And then square root, the length is what? 4 square. Is that not so? Am I hearing 9 square from somewhere? 4 square. Is that not so? Plus breadth is what? 4 square. And then our height, do we know it? No. If you work on this, you're going to get, please, we don't have time to waste. So watch something quickly. Are you following? Watch something quickly, process with the network of your brain. 4 square will give you 16, 16. 16 plus 16 is 32. So this is 32 plus h square. Are you getting me? And it is covered by square root. If you are looking for something and that thing is covered by square root, what do you do? Don't tell. I said, what do you do? I didn't tell you to solve it for me. I want all of us to be aware of this. What do you do? Take square, not square root. Take square, not square root. I said you're looking for something that is covered by square root. So you take square to remove the square root. If you are looking for something and that thing has square, understand this thing before you go do something else. If you are looking for something and that thing has square, what do you take? Take square root. Are you following, right? So we go. So since the unknown part here has square root, please take what? Square of both sides. Am I communicating? And I'm not going to show you that. If you take square of this left-hand side, what will it become? Equal to 32 plus h square. Am I correct? Because if you take square of this guy bearing square roots, the square root will do what? Disappear. The square will cancel the square root. Are you following, right? Let's take it off. Now you have to make h square subject of formula. So from here, what do you do to make h square subject of formula? You collect like terms. You are looking for something and there is plus or minus between that thing and something else. You collect like terms. Understand all these basic maths I've been saying that time and again. If I collect like terms, I'll have h square equal to 81 minus 32. Is that not so? 49. Therefore, the height of this guy will be what? 7 centimeters. You know how we got the 7. Is that not so? Take square root. All right. So I hope we understand what we solved here, right? We are given the length of the diagonal of the cuboid. You know that the cuboid is made of a square base, so the length and the breadth are the same thing. Are you following? You have to find the height, apply the length of diagonal formula of a cuboid, and then substitute. Let me ask you, what is the formula for length of the diagonal of a cube? Because this could have been a cube. Is that not so? This could have been what? A cube. What is the formula for the length? Square root of L raised by 3. No, length of diagonal. L square root of 3. L times square root of 3. Or if you want to take the L into the square root, it will be square root of 3L square. Are you getting me right? For cube. For cuboid, this is the formula. Okay, let's move on to the next question, please. The area of the curved surface of a cone. The area of the curved surface of a cone. The area of the curved surface of a cone generated by the sector of a circle. The area of the curved surface of the cone generated by the sector of a circle. I hope we are there, right? Radius 6 cm. Radius 6 cm and arc length 22 centimeter. Interesting question. The area of the curved surface of a cone generated by the sector of a circle, radius 6 centimeter and arc length 22 centimeter. And arc length 22 centimeter is, so we don't know. Are you getting me right? Now in bracket, pi equals 22 over 7. In bracket, pi equals 22 over 7. I read the question for the last time. The area of the curved surface of the cone, of a cone generated by the sector of a circle, radius 6 centimeter and arc length 22 centimeter is, we have the options here. 58 square centimeter option A, option B 34 square centimeter, option C 132 square centimeter, option D 66 square centimeter. So let us attack this question. It is 1 plus 1. Like I said, it's all about you reading the question, bringing out the information given to you, thinking of the formula, substituting and simplifying. So my question is, this particular question that the exam body asked us is based on which shape? Cone. That is what they're asking us question on. But did you notice the technicality in this question? It is not directly cone. Are you getting me right? It's not directly cone. It is cone formed from what? Sector. They now gave you some information about the sector. In fact, this question, the examiner helped your ministry. If they had want to punish you, they would have given you the angle subtended by the word sector to force you to calculate the radius of the circular word base from that angular something. But they helped you here. In fact, they gave you a lot of good information in this question. Let us extract the information in this question. Are you getting me right? Please look at your question. What are they asking us to find here? What are we looking for here? What are we looking for? The area of the curved surface. That is simply curved surface area of the cone. Are you getting me? So a curved of the cone we don't know. Are you following? What and what were given to us in this question? The radius of the circle. Take note of that, so you don't go and use a wrong parameter. I'd like you to read that line, please. Read it uniformly. Like choir singing. I'll tell you where you should read from. Let's see. Start from generated by. Are you ready? Okay, start. So that 6 centimeter is radius of what? Thank you very much. So you don't misinterpret it to be radius of the cone. Are you getting me right? It is radius of the circle. So permit me to use RC like this. Radius of the circle. Circle cone. Both of them started with what? CC. So let me make it out. Okay. Let me just use this capital letter for the circle. Are you getting me? But another problem is that C, small letter and capital letter, they look alike. Okay, no problem. The R here, let's use capital R here. I think it's better. That is going to be 6 centimeter. You know it is for the circle. Even when we are generating something like that, use capital R. Are you following right? Yes, let's proceed. Further information given to us in the question. Length of what? Of the arc of the sector. Okay, so arc length. What's the value? Good. These are the key information. Pi is 22 over 7. We are aware of that. Are you getting me right? How do we process this information? We are looking for the curved surface area of a cone. Curved surface area of a cone, what is the formula? Pi r slant height. Is that not so? Now, see our problems here. Do we know the slant height of the cone from this question? Do you know the slant height? Let's get our, where is, I gave it to you. Have you destroyed it? Bring it. Because I was saying this when I interpreted this concept. This is our sector. Is that not so? Is that not so? These are what? Sector. This radius is radius of what? Of the circle that the sector is part of. That the sector was obtained from. Are you getting me? This is the radius of the circle. If I now fold this thing like we folded that time, be watching what is happening to the radius as the cone is forming. The arc already forms the circular base of the cone, is that not so? So the arc length will be equal to the circumference of the circular base. But now watch what is happening. Original radius of the circle, which is the same as radius of the sector, you are now folding to get your cone. You are now folding. You have gotten your cone. You have gotten your cone, is that not so? Now look at this thing. This edge here and this edge. This edge. You know, this is the slant edge of the cone, is that not so? It's gotten from what? The circle. What about the circle? The radius of the what? Circle. So what are we saying in essence? Anytime you form a cone from a sector, the slant height of the cone is equal to the radius of the sector, or simply the radius of the circle. Are you getting me? Which means this guy you are seeing here implies that slant height is equal to what? 6 cm. Are you following right? Are you following? I've shown you the radius of the sector, which is the same as the radius of the circle that the sector was gotten from. That radius is the same as the slant height of the cone you would obtain. You saw it yourself. Are you following? When I folded, the radius became what? The slant height. So once you know radius of any circle, and you get a sector from the circle, the radius of that circle is the slant height of the what? Cone that will be formed from the sector. So we don't have problem with this L. Is that not so? We don't have problem. But we are not yet at the point of solving this question, because there's another problem we have here. To apply this formula, you must know R, which is radius of the cone. Is that not so? I must know the slant height. We have gotten the slant height. It was given to us directly in the question. What about the radius of the cone? Do we know the radius of the cone at this point? No. The radius given to us here is radius of the circle, which is equal to the what? Slant height. So how do we now get the radius of the cone? Question. You have a cone, something like this. Is that not so? Which part of the cone do you get your radius from? You know, a cone is made up of something like triangle, you know, those slant height, and then something like this. So which part do you get your radius from? Is it this part or this part? This part, is that not so? This shape is what? Circle, Abi. This circle, which is the base of the cone, is gotten from what? In the sector. The arc length of the sector, is that not so? They now gave you the value of the arc length, true or false? You know it is the arc length that gives you the circular base. So the length of the arc must always be the what? Perimeter, the circumference of the circular base. They gave us the length of the arc. So all we have to do is to make this equal to circumference of what? A circle, and get our radius of that circular base there. Are you getting me right? So we go, let's do that. Let's do that. Let's do that. Now, we know that circumference of the circle, capital C, are you following right? Which is the perimeter or the length of the circle, will be equal to the length of the arc. Are we together? The circumference of the circular base of the cone. Okay, now, I can't write all those grammar here. The circumference of the circular base, the perimeter of the circle of that cone, is equal to the length of the arc, because it is gotten from that arc. Are you getting me right? Irene, your face, I don't know if I can interpret. What is happening? You don't understand. What exactly is the challenge? To be fast. What is it you don't understand? Is it that we say that this radius of the sector or the radius of the circle is the slant height? Do you agree with us there? You agree there. Okay, so what exactly is not the problem? They gave us length of the arc from the question. I wrote it out.
How you're taking
circumference of the circular base of the cone. That's what we are saying. Remember we said when you have your sector, are you following? I hope you've traced the shape, right? That curve, which is the arc, if you fold the sector, it is that length of the arc that gives you the circular base of the cone. Now, is that not so? Therefore, the length of the arc is equal to the length of the circular base, which is perimeter of the circle. So that is it. Now, What is the formula of circumference of a circle or length of a circle or perimeter of a circle? 2 pi r, remember so? And that's equal to length of the arc given to be what? 22. Make r subject of the formula. It's going to be 22 divided by 2 pi what? Okay, 2 pi, is that not so? Substituting 22 over 2 times pi is what? 22 over 7. Are you following, right? Therefore, the radius of the cone, which we are using small letter r, is equal to, come over here, this 22 and 22, it cancel. I hope you know that. Mathematically, this denominator of this fraction will do what? Go up. Are you following? This 22, 22 will go up, 7 will go up. So radius is 7 over what? 2. Is this clear? Our problem is solved though. Our problem is solved. It implies that the curved surface area of the cone is equal to, you substitute 22 over what? 7 times the radius is what? 7 over 2. The slant height is what? 6. 7 will go off. 2 and this will go. You have 3. 3 times 22 is going to give you 66 square centimeter. Square centimeter. This is an abbreviation for writing square centimeter if you don't want to write it in full. They used it there. Are you getting me right? So if you see that, it's the same as writing cm to the power of 2. So we are done with this question. We are done with this question. Let's move on. Fast. Yep. Someone is asking, did they ask us to look for the radius? Or is it area of the curved surface? You know, your question just made everyone laugh, you know. It is the area of the curved surface that we're asked to find. And this is the formula, is that not so? But there is no way you can solve for this area if you don't know radius. The area depends on radius. So you must know your radius, you must know your slant height. Good enough, the slant height was given to us, but they didn't call it slant height. It's left for you, and that's why I demonstrated all those things in class here. It's left for you to be aware that this radius of the circle is the slant height. So the radius of the cone now, we needed to find it so that we can substitute into this formula to calculate that. Is that clear? We have gotten what they asked us to get. Now look at, all right, don't worry, look at the board. We have gotten that radius here. Law of diminishing return is setting in now, right? It's understandable. We'll soon round up. Be fast. Next question. A solid hemisphere has radius 7 centimeter. A solid hemisphere has radius 7 centimeter. By the way, this question that we just solved, you know, I read out the options earlier, so it's 6 square centimeter. A solid hemisphere has radius 7 centimeter. Find the area. Find the total surface area. A solid hemisphere has radius 7 centimeter. Find the total surface area. Once again, you are taking pi to be 22 over 7. A solid hemisphere has radius 7 centimeter. Find the total surface area. Pi is 22 over 7. You're asked to take it. Option A is 400 square centimeter. Option B is 462 square centimeter. Option C is 66 square centimeter. And then option D, 308 square centimeter. This is JAMB 2002. I'm wiping here. That should be question number what, please? 5, JAMB 2002. Now, first of all, this question is based on which solid shape? Hemisphere. And they gave us the radius. Of course, the formula of hemisphere and sphere depends on radius only. I hope you know that, right? The pi there is constant. It has a specific value assigned to it. So this is a very simple question. We asked to find total surface area of a hemisphere. So A total we don't know. And we know the radius to be 7 centimeter. What is the area of total surface? What is the total surface area of a hemisphere? Area of the top circle, is that not so? Plus curved surface what? Area. Which give us 3 pi r what? Square. So we write out the formula 3 pi r square is the total surface area of a hemisphere. The curved surface area is 2 pi r square, is that not so? And yeah, curved surface area of hemisphere is 2 pi r square. You obtain it by dividing area of hemisphere by 2. I told you that, isn't it? So curved surface area of hemisphere is 2 pi r square. Then the circular top is pi r square. If you add them, you get 3 pi r square. So it's just about you remembering the formula. Are you getting me right? If you substitute, what would you get? You and this your smiles always. I hope it's entering, Abi. I hope it's entering. Abi, don't choke. Okay, so let's move on. 3 times 22 over 7 times. This is r, which is 7, you square. That 7 square is same as 7 times 7. Are you following, right? So, oh, you want to go and write 49 there? Even if I put it as 7 square. 7 square. If you want to apply indices law, you can apply. 7 over 7. Which law of indices can you apply? 7 over 7. Which law of indices can you apply? Division law. Say pick one of the 7, maybe the one at the top. Then 2 minus the power of this one. Is that not so? But it's a waste of time. This 7, we remove this 2. Are you following that square there? Multiply this. Are you ready? This is 66. Is that not so? 66 times 7 will give you what? 462. That's the total surface area of this guy. Once again, it is all about you remembering the formulas. Are you getting me? Remember the formula. Always remember the shape you are dealing with. Create a mental picture of it so that if there is any challenge, you can use it. Number 11, we are done with it. I won't solve it. Someone is giving us a question from WAEC. Is that not so? Number 11, but I won't solve it. I'll just show you on the board. We've treated that, I think, last class or so. Under plane mensuration, we have a diagram like this. That is WAEC 1992. We have something this way. And then, we have something this way. So, favor, take notes. This is not a cone, actually. It's not analyzed as a cone, this one. This is a straight line. Are you getting me? I think it's a sector together with segment. Here was shaded in what I'm seeing here. They gave us here to be 10 centimeter. You could solve it as a personal work at home. Are you following right? They gave us here 10 cm, 10 cm, and then we have this angle to be 63 degrees. And the question says, calculate the area of the shaded segment of the circle shown in the diagram. So this is a segment problem, not part of what we are treating. Are you following? If you check your notes, you see the formula. Calculate the area of the shaded portion, they said, isn't it? Yes. What is area of segment? I told you that it is area of a sector. An area of a sector is what? Theta over 360 times pi r square. This whole thing with this curve is a sector. Then minus the triangle you have there, which is what? Half r square sine theta. That gives you that guy. Let's move on to the next question on our solid mensuration, please. The next question, please write. JAMB 2008, question today is what we are dealing with here is question 6. JAMB 2008. Let's see what we have there. But of course, if you see any question on solid shape from WAEC, bring it out. Are you following right? Bring it out. Okay, we have this question. Find the capacity in liters. I love this question. Find the capacity in liters. Follow up with what we are dealing with. Follow up. If you open to, you don't need to be turning up and down. Once you open to that page containing it, you can see a lot of questions. All right, maybe I'll pick one from there. Find the capacity in liters of a cylindrical well. Of a cylindrical well. You know your well, most of them, the way it's been dug. Are you following, right? It's cylindrical. Goes down. Good. Find the capacity in liters of a cylindrical well of radius 1 meter. Of radius 1 meter and depth 14 meters. And depth 14 meters. Find the capacity in liters of a cylindrical well of radius 1 meter and depth 14 meters. You are still to take pi to be 22/7. Now we have the following options: 44,000 liters, option A. Option B is 4,400 liters. Option C, 440 liters. Option D, 44 liters. So how do we attack? I am not reading the options for you to write. I'm not interested in that. I'm just as a kind of reading it out randomly. If you want to copy the option, later at the end of everything, a copy of this, our class will be made available. So you can always go and check. This question is based on which solid shape? Cylinder. And what were you asked to find? Capacity. Another word for capacity as mentioned, volume. So at this point, you should start cracking your brain, brainstorm, so that the formula for volume of a cylinder would come out. Are you following, right? So I'm going to ask somebody to tell us the formula for volume of a cylinder. But before then, let us look at the values given to us. Are you there? Let's look at the value. In the question, they gave us the radius. Radius is 1 meter. We were given the depth. Depth is the same as height. You know, the only thing is that if you are going down, you talk about what? Depth. If you are going up, you talk about what? Height. So that depth, you are still going to use H for it. And the height is how many centimeter? 14 meters rather. It's not in cm. 14 meters. So with this, you are calculating the volume, the capacity. The formula is pi r squared what? H. I think this is the formula, isn't it? So all you have to do is to substitute 22/7 times the radius 1 meter you square times the height 14. Is that not so? 7 can divide here, you get 2. 1 square is 1. 2 times 22 will give you what? 44. You want to be careful at this point now. Watch the board, all of you. If you have problems with conversion. You see this volume you calculated here? What is the unit? What's the unit of this volume? Correct. Because you calculated this capacity, this volume, using meter quantity, as in meter as unit. Are you following, right? So the SI unit of this will be what? Cubic meter. But you were asked to calculate this in what? Liter. So you now have to crack your brain and think of the conversion factor. In physics, I've given you the conversion factor. Physics and chemistry. In chemistry, I've given you the conversion factor here. 1 liter is equal to 1,000 cubic meter. 1 liter. But we can actually find out. Are you there? I know that 1 liter is the same as 1 dm cube. This one in chemistry, we made it a lot. Dm cube is decimeter. That D there is deci. And deci is 10 raised power minus 2. Are you following, right? I'm telling you this so you get to know what all of these things are. Which means that 1 liter converting to meter cube will be, this deci is a number. It's what I said. Deci is 1 divided by 1/10, not 100. Deci is 1/10, which is 10 raised per minus 1. Pay attention to this. If not these days that some of all these book manufacturers, what they draw at the back of your book is Indomie and tomatoes. You know, in those days when we were in school, you see all these conversion factors. Deci is 10 raised per minus 1, which is 1/10. Centi, you've heard of centimeter, right? Centi is 10 raised per minus 2, which is 1/100. Kilo is times 10 raised per 3. Are you following, right? So look at the conversion factor, please, so that we know what to do here. I don't want to give you any wrong thing. See it yourself. Are you following, right? 1 liter is the same as 1 dm cube. Are we together? Converting this now to meter cube so you see the relationship. dm, I've told you that dm is times 10 raised power minus 2, which is the same as over 100. Is that not so? I have changed this dm you are seeing here, dm cube. This raised power 3 is affecting both the d and the n. People should focus and understand this, especially the science students. This cube you are seeing here is affecting both the deci and the what? Meter. So that if I change this deci to 10 raised power minus 1, not 2 rather, are you following, right? I'll fix the meter here. This 10 raised power minus 1 represents what? D. Both of them will be raised to power what? 3. Many people are not aware. Yeah, anyway, let me say some are not aware that this 3 is affecting. They think that is this meter that is affecting only. And that is why sometimes when it is time for you to do certain conversions, you get into trouble. If you know one particular conversion in any quantity, it's sufficient for you to actually deal with every other conversions of that quantity. So we proceed. 1 liter, I want to get the equivalent in meter cube now. Are you getting me? 1 liter will now be equal to, I told you that power distribute over multiplication. I've said that time and again. This dm you are seeing means deci times meter. Are you getting me, right? Deci what? Times meter. So this will be 10 raised power minus 3 times meter. This 3 will be distributed. Are you following, right? This is 10 raised power minus 1 times this power 3, which will give you 10 raised power minus 3 and then meter cube. So this is the conversion factor. Every 1 liter will give you 10 raised power minus what? 3 meter cube. You can still rewrite this thing in this way. 1 liter is equal to 10 raised power minus 3 is the same as 1 over 1000. Are you aware? Then meter cube. If you cross multiply, 1000 times 1 will give you what? 1000 liter. Are you getting me, right? If you do what? Cross multiply. Equal to what? 1 meter cube. So I feel like you people will prefer this one. So you are meant to cram it. Every 1000 liter will give you how many meter cube? 1 meter cube. Now, how many meter cube do we have here? So if we know that 1 meter cube is equal to 1000 liter, 44 meter cube will be equal to what? 44 times 1000. So I've shown you how you get a conversion. All you just need to cram is this. However, don't just end at cramming. If I just wanted you to cram, I would have just told you. You know, I told you earlier, multiply this by 1000. Is that not so? But I saw the need to show you the implication of this. Are you following, right? Therefore, we could say that the capacity is 44 times 1000 liter, which is 44,000 liter. That's the answer. We are done with this question. Next one fast. Next one fast. I'll dictate this one, but we may not solve it together here. You can solve it when you get home. Are you following? Finish up this. I'll dictate this. We won't solve it together. The reason is because it is a cylinder problem. We have solved cylinder problem already. It's sufficient. Even if it is the volume that they asked us to find. Let's do a round off. Are we together? Like I said once again as a reminder, and that is how interesting maths is. Out there. No cho. Are you getting? Get the formula. Know the formula. When you are exposed to a question, read the question, interpret it. Are you following, right? You should always be able to identify the values given to you. And take note of what you are asked to what? Find. And once you remember the formula, the problem is solved. It's not like physics, chemistry, sometimes you may go left, right. Are you getting me, right? It's not like that. Math is very simple and interesting. And as simple as it just picked up. I'm not talking much about most of you here because the exam is just started. Interested in your younger ones. Talk to them. Encourage them. They should take their math seriously. Are you following, right? And most importantly, multiplication table. I've said this before, your ability to memorize that table from 2 to 9 times table already expands your brain. They're about 60%. It becomes easy for you to quickly understand things. Are you getting me right? So don't joke with it. I'm wiping. Next question. Question number 6. Number 7. I think this is number 6.
Yes.
So number 7. Now, I will give you this one. Go solve it at home. Right. That is 2010 JAMB. Question number 7. A cylindrical pipe 50 meter long with radius 7 meter. With radius 7 meter. Has one end open. Has one end open. A cylindrical pipe 50 meter long with radius 7 meter has one end open. Full stop. What is the total surface area of the pipe? What is the total surface area of the what? Pipe. What is the total surface area? Option A. Make sure you get the correct values given. Option A is 700 pi square meter. Option B is 98 pi square meter. Option C is 350 pi square meter. Option D is 749 pi square meter. That's JAMB 2010, like I said. Now, I want to ask you a question. Do you need the value of pi to solve this question? No. The options, the final answer is expected to contain pi. So you don't need to substitute for pi there. Are you getting? What shape is this question based on? Cylinder. What about the cylinder are you asked to find? Area when one end is. So take note. Take note. It's not the total surface area. And it's not the curved surface area. It is the area when one end is what? Open. Which means one end is what? Closed. I analyze that. You need one of the circular bases and the curved what? Surface area to solve it. Let's move on to the next question, please. Question number 8. Question 8. A solid metal cube. A solid metal cube. That is JAMB 2011. A solid metal cube of side. I love this question still. Just saw it, I love it. A solid metal cube of side 3 cm is placed in a rectangular tank. Please follow up with the question. A solid metal cube of side 3 cm is placed in a rectangular tank of dimensions 3, 4 and 5 centimeter. Of dimensions 3, 4 and 5 centimeter. A solid metal cube of side 3 centimeter is placed in a rectangular tank of dimensions 3, 4 and 5 centimeter. That is 3 centimeter, 4 centimeter and 5 centimeter. Are you following? Sometimes this dimension can be written like this. Watch. 3 cm by 4 cm by 5 cm. If you see this thing, this is length, breadth and what? Height. You see that they use these times like this to show it, or they use the word by. Are you getting me? So if you see that, don't get confused. Good. What volume of water can the tank now hold? What volume of water can the tank now hold? What volume of water can the tank now hold? This is an applied question. It requires sense, enough thinking. Create the mental picture of this diagram and just imagine you are the one that is doing this. What do you expect? Okay, so we have option A, 48 cubic cm, B, 33 cubic cm, C, 60 cubic cm, and then D is 27 cubic centimeter. What is this question based on? This question is based on what? JAMB 2011, I said, is that not so? Are you sure it is based on cube? It is based on both of them. It's based on both the rectangle and what? The cube. However, the question they ask is, what? What volume can the what? The tank now hold. Is that not so? Okay, so the question is actually based on the rectangular tank. A rectangular tank, do you know the shape? A rectangular tank, do you know the shape? There is this tank that welders used to construct in those days before these GP tanks. Are you following, right? Came and stuff like that. That guy is a cuboid. It's what? It has a length, a breadth, and what? The height. Then you store water in it. Are you following, right? So look at what the question is all about. You have a cuboid. A cuboid has volume, so it can contain water. Are you following, right? You now took a solid cube and put inside. Now I have a question for you. If there is no solid cube inside, you know that the cuboid, that's the rectangular tank, will be empty to fill any quantity of water you are putting to occupy the volume. Is that not so? Now, if you put the solid cube into it and you are pouring water, the volume that the tank will contain when there is no solid cube and the volume that the tank will contain when there is a solid cube, which one will be greater? When there is what? No solid cube. This thing is common sense. It is what? Common sense. You have this thing here like this. If this can is filled with water, and now on your own you decided to pour off the water, then you get stones and fill this can with stones, but not completely. Are you getting me? Then you now went ahead to start filling it with water. If you measure the quantity of water, the capacity that this guy can hold when there is nothing inside, and what it can hold when you now put something inside, when nothing is inside, it will contain more volume. Are you getting me? Like I said, it's common sense. When the cube enters there, the cube will occupy space. True or false? The cube will prevent some water to enter. The space that water is supposed to occupy, the cube will do what? Occupy it. Now, all of us have agreed that when the guy, there is no cube in it, it will contain more volume than when there is cube. Is that not so? So all you just have to do, by the time you put the cube there, for you to know the volume that it will now be occupying, it will be the total volume of the tank. Are you getting me? Then remove the space that the cube will be doing what? Occupying. And the space the cube will be occupying will still be the volume of the cube. Is that not so? So to solve this question directly, give me the parameters, please, the dimension. For the cube, length of the cube is what? Length of the cube is what? 3 cm. Now, what is the dimension of the cuboid? For the cuboid, we have length to be what?
3.
Breadth to be what?
4.
Height to be what? To get the capacity, the volume that the cuboid can now contain with the cube inside. Volume will simply be volume of the cuboid minus what? Volume of the cube. That's just the formula. You know, I had to, that's the formula now. So you simply just calculate the two volumes and do your subtraction. I just decided not to approach it directly. Rather, I explain to help you understand how to handle certain problems. If you have an applied question like this, you don't need to get scared. So we go, volume is now going to be, volume of cuboid is what? Length times breadth times height for the cuboid. Is that not so? Then minus volume of cube is what? Length cube for the cube. So substituting, do you see that in example, you really don't even need to solve this question? Are you aware? Like, you don't need to stress yourself solving. Because all you just need to do is, all you just need to do is multiply 3 by 4 by 5. You get the volume of the cuboid. And then subtract the volume of the cube. 3 cube is 27. Is that not so? Okay, let's go. 3 times this is what? 4. 3 times 4 is 12. 12 times 5 will give you what? So 3 times 4 times 5 minus 3 cube. So this is going to give you 60 minus 27. And you said it's what? 33 cubic cm. So that is it. Very simple question. Are you following right? But the way the question was presented, if you are not confident in understanding that these things are 1 plus 1, you might just get scared. So you see, we are not even supposed to spend the time I spent on solving this question. Next question. We have 3 more to solve as we close. Out of the 3 more, we may not solve all 3 because some of them might just be repetition of these guys. After the people WAEC, JAMB, all of them, they cover the same thing. Let me have. So let's take one. WAEC question is what? WAEC question is nowhere above anything. You should not allow anybody to deceive you. These things are the same. But you are, wait, favor, this thing is still on plain majoration. Were you not in class when we treated plain majoration? Okay, that is why now you're busy opening these things. Okay, so let's see. You know, it is still the same thing, like I said. So we don't need to be stressing ourselves. What a WAEC question, JAMB question for what? That's trash. These exam bodies, they cover the same kind of questions. Are you following, right? Okay, I have this question here. Are you there? A boy, I won't solve it. Take note. It's too simple to interfere with it. It's too simple. It's not. I just want to read out the question. And a boy blew his rubber balloon to a spherical shape. A boy blew his rubber balloon to a spherical what? Shape. A boy blew. You know, to blew something. B-L-E-W. I want me to say a boy blew. A boy blew his rubber balloon to a spherical shape. You see, they have already told you the shape under consideration here. Are you following, right? The balloon burst when its diameter was 15 centimeters. The balloon burst when its diameter was what? 15 centimeters. Calculate correct to the nearest whole number. This question is theory 2001. WAEC 2001. Calculate correct to the nearest whole number. Calculate correct to the nearest whole number. WAEC 2009. You know, the only thing that happens here is 2001 rather. They'll just use grammar and confuse you. And you think there is anything significant there. Calculate correct to the nearest whole number the volume of air in the balloon at the point of bursting. Calculate correct to the nearest whole number the volume of air in the balloon at the point of what? Bursting. So we are going to find out whether WAEC question is different from JAMB question. Maybe the formula we use in solving this one now is no longer the formula we use in solving JAMB's own. Are you getting me? I really want you guys to be aware of this. They said calculate the volume of, calculate correct to the nearest whole number the volume of air in the balloon at the point of bursting. Are you there? So it's just grammar that they use in trying to confuse you. Are we together? It's theory question, so there is no option. Now I want to ask you, at what point did the balloon burst? When the diameter was what? 15, what is it, cm or meter? 15 cm. So when the boy is 15 centimeters. Once it was 15, you heard, pop! It has happened to some of you. You know, now you play, you want the balloon to fill everywhere. You don't know that there is a size of air it can contain. When you go past it, the next thing it bursts, and you feel the pain here. To fire your cheeks and lips. Cheek, has it happened to you before? So when the balloon bursts, at the time that the balloon bursts, the diameter of the balloon, which is approximated as a sphere, are you getting me right? The diameter was given as what? 15 centimeters. Is that not so? The formulas I gave you for sphere, you know, you could bring in diameter there if you want. Are you getting me right? Radius is diameter over 2. So diameter is 2 times what? Radius. But since all the formulas contain radius, why stress yourself with the diameter? Is it not to change to radius? To change this guy to radius, what will you get? 7.5. I want to believe all of us know how we got it. Chidima, do you know how we got the 7.5? To change the diameter to radius. Radius is diameter, you divide it by 2. Are you getting? The diameter is 15. So you divide the 15 by 2, you get 7.5. You are asked to calculate the volume of the air in the balloon at this point. Now take note. The volume of the air is the same as the volume of the balloon when you blew it. Are you getting me right? See, air is a gas. And if you have a balloon, you are filling it with air. As the balloon is expanding, the volume of the air is the total volume of that size you are seeing. Are you getting me right? Are you getting me? So go straight and calculate volume of sphere. That's just what they are asking. Don't think that there is something about the air. How can I calculate volume of air? GMAETS 41 did not teach us volume of air. You can't calculate the volume of air. Are you getting me? You filled the air as a gas into the balloon. The air gave the balloon a shape. So the volume of the air will be equal to the volume of what? That shape. Is that clear? Is that clear? What is the volume of a sphere? You don't finish, oh. So you substitute. V equal to 4 over 3 times 22 over 7 times 7.5 raised to power what? 3. And then you simplify. Multiply this out, tell us. Multiply and tell us. Just give me the final answer. We don't have time. Otherwise, I would have said we should work it out. But see, let me tell you something. The best thing one could have done if you were to be in exam hall, the best thing you could have done here, in order not to use calculator, is to maintain this 15. You see this radius? Write it as 15 over 2 instead, so that there will be no decimal. Are you getting me? So that there will be no what? You know, now I want to use calculator, just evaluate and tell me the value. However, if you were to be in exam hall, it will be better you don't change this in the decimal since it is Q. You now come over to this, you are working 4 times 22 over 3 over 7 times, this guy is 15 to the power of 3 divided by what? 2 to the power of 3. This is 8. 15 cube, you can work it out. 15 times 15 is 225. Is that not so? Times the other one, multiply out, and then you start reducing. You start doing what? Reducing. This is 4 over 3. You start doing what I said? Reducing. What did you get?
1,767.85.
1,007 what?
767.
So the value is 1,767 point what? 0.85. Now you were asked to put the answer in the nearest what? Whole number. So you are meant to round off from the 10th place value to the what? Unit place value. 8 is up to rounding up. Is that not so? So add 1 to this. It therefore means that our answer will be what? Please, I need that value again. Volume equal to 1,700 and what? 67.8. In the nearest whole number is going to be approximately, all right, take care. Okay, it's going to be approximately 1768 cm what? Q.
Students are complaining about complaints because many of them didn't come to class. So when I asked, they told me that those ones have changed that because of
It's their business. They're not going to do about that. We don't hold anybody here. We can only provide what we are able to provide.
so is it an problem because of the next coming?
No, on Monday, because of one thing, he had an adjustment in schedule. But arrangement is being made already. Please, you have to wait for me a moment. Huh? Arrangement is being made already. So you don't bother about it. Anybody has decisions to make. We're not against anybody. All right. I was trying to show you how you could attack this question without calculator. You don't need to convert this to decimal. Are you following, right? That 15 raised by 3 over 2 raised by 3, you can start reducing. Are you following, right? First to get it. Okay, so that is it. Chuku, you can see now that there is nothing there. Are you following, right? Other ones are still in line with everything we've been doing, okay? So you can solve them. Please, let us round off. Let us round off. I'll give you this one, calculate it at home. I think we are even done. So let me just give you all those questions. We are done. But I'll dictate them for you. Are you getting me? Right. Question number 10, Abi. Question 10, because this WAEC only is 9. This WAEC only is 9. Okay, calculate this JAMB 2012. Calculate the volume of a cuboid. Calculate the volume of a cuboid. Calculate the volume of a cuboid. 0.76 centimeter. Calculate the volume of a cuboid. 0.76 centimeter, comma. 0.76 centimeter, comma. Breadth 2.6 centimeter. Breadth 2.6 centimeter. Breadth 2.6 centimeter. And height 0.82 cm. And height 0.82 cm. Remember, the first value given is the length, but it was not mentioned. I'm reading exactly what I saw here. It could be typographical error. Now I'll give you options since you are meant to solve it. So you have something like this. Silence. Option C, 1.97 cm cube. Option D, 1.6 centimeter, 1.62 cm cube. So that's the option. Those are the options there. Then the next question. Fast. I think I should even be copying the question on the board. The next question, which is question what? 11. A cylindrical tank has a capacity of, I love this question, 6,160 cubic centimeter. What is the depth? What is the depth of the tank? What is the depth of the tank if the radius of the base is 28 meter, take pi equal to 22/7, and then have these options: A, 2.5 meter, option B, 8.0 meter, option C, 7.5 meter, option D, 5.0 meter. This is 2014 rather. 214 JAMB. Now you want to watch out. Look at this question. You can see certain mix-up. They gave you the capacity. Another word for capacity is what? Correct. So you were given the volume. What is the unit of the volume? Oh my gosh. What is the unit of the volume? I could have any this thing there. Any type C quickly there, so that I'll prevent it from going off. Any type C there. So sit down, don't worry. Sit down. We are done already. Those online, at least you've learned the things you're meant to learn. I'm just giving questions.